Hello, grade 4. How are you? Are you okay? I hope so. Today, we will talk about symmetry. Symmetrical figures and lines of symmetry. Let's watch together this video to understand the meaning of symmetry.
Line of symmetry. Students, today we are going to learn about line of symmetry. A line of symmetry is like a mirror line. One half of the shape looks like the reflection of the other half. In other words, if you can fold a figure in half so that two halves exactly match, then the figure is said to be symmetrical. Let us practice drawing line of symmetry for different figures. We can fold a rectangle equally in two ways. Diagonally, you can't fold a rectangle into equal parts. A rectangle has two lines of symmetry. In a square there are four lines of symmetry. It is symmetric along two midpoints of opposite sides, and the two diagonals. A regular hexagon with 6 equal sides has 6 lines of symmetry. Interesting, isn't it? A circle has a countless numbers of lines of symmetry. That means wherever you fold on these lines, it will be exactly half to its other side. Try observing line of symmetry in shapes around you. You will come up with so many interesting points.
Line of symmetry. Look at this figure A, B, C, D. X, Y, X, Y represent a line of symmetry. X, Y represent a line of symmetry. For the figure A, B, C, D. Figure A, B, C, D. If A, B, C, D is folded around X, Y, fold this part on this part, okay? Such that the right part is congruent with the left part. In this case, the figure A, B, C, D is a symmetrical figure around this line. Please don't forget X, A, B, Y is congruent to X, D, C, Y. Drill 1. Determine the symmetrical figures of the following and draw one line of symmetry for each of them. Figure 1, Figure 2, Figure 3, Figure 4, Figure 5, Figure 6, Figure 9. These figures are symmetrical figures. We can draw one line symmetry for these figures, but figure 7 and figure 8 is non-symmetrical figures. We cannot draw line of symmetry for these two figures, figure 7 and figure 8. Is there more than one line of symmetry for some of these shapes? Excellent. Yes. Look, figure 1 has 2 lines of symmetry. Figure 2 has 3 lines of symmetry. Figure 3 has 2 lines of symmetry. Figure 4 has very large number of lines of symmetry. Figure 5 has 2 lines of symmetry. Figure 6 has 1 line of symmetry. Figure 7 and figure 8 don't have any line of symmetry. Figure 9 has 1 line of symmetry. If your answer is yes, name these figures. Then draw those lines. Are there any of the above figures with no line of symmetry? If your answer is yes, determine them. Excellent. From the above, some geometrical figures have one or more lines of symmetry, symmetrical figures, and some other geometrical figures have no line of symmetry, non-symmetrical figures. Drill 2. Let straight line AC be a folding line. Straight line AC is folding line. Note the parallelogram A, B, C, D. Parallelogram A, B, C, D. When folded, then answer fold the parallelogram around the line of folding, okay? Then answer is B congruent to C? Excellent. Now, is triangle A, B, C congruent to triangle A, D, C? Look with me. This parallelogram A, B, C, D. This is folding line. Now we will cut these two triangles like this. Rotate this triangle like this. Now we have two triangles. The first triangle A, B, C. The second triangle C A D. Now we have two triangles. Triangle A B C and triangle C D A. Now we can say A B C is congruent to C D A. Again, triangle A B C is congruent to C D A. Pay attention. The triangle A B C is not congruent to A D C. Back to our question. Is triangle A B C is congruent to A D C? No. Is AC straight line AC a line of symmetry for the figure A B C D? No. AC is not a line of symmetry for the figure A, B, C, D. Is A, B, C congruent to A, D, C? No. Why? Because A, B, C is not congruent to A, D, C. Pay attention. Triangle A, B, C is congruent to C, D, A. From the above, we can say that if there is a line which divides a figure into two congruent parts, is not a must to be a line of symmetry of this figure. Drill 3. Note the figure opposite, then complete. The figure A, B, C, D is a rhombus of side lengths approximately equals. Excellent. 2 centimeter. The side lengths of AB equal 2 centimeter. 1, 2. Draw straight line BD. Like this. Is straight line BD a line of symmetry for the figure A, B, C, D? Yes. Because the triangle A, B, D is congruent to triangle C, B, D. Check that AC, straight line AC, is another line of symmetry for the figure A, B, C, D. Like this. AC is another line of symmetry for figure A, B, C, D. Because the triangle ADC is congruent to triangle ABC. From the above, the rhombus has two lines of symmetry. Drill 4. Note the two drawn figures, then answer. Complete each of figures 1 and 2. Figure 1, figure 2 is called a trapezium. This figure is trapezium. This figure is trapezium. But figure 1 is an isosceles trapezium. Figure 1 is an isosceles trapezium. And figure 2 is non-isosceles trapezium. We can also say scalene trapezium. Now answer is MN. Is straight line MN. Now try to answer. Is straight line MN a line of symmetry for figure 1? Why? Figure 1. Straight line MN is a line of symmetry. Yes, because the figure AMNB is congruent to DMNC. Is straight line HW a line of symmetry for figure 1? Why? No, because there is no line of symmetry called HW. In figure 1, there is no letters H and W. Okay? Is straight line AC a line of symmetry for figure 1? Why? Straight line AC is not a line of symmetry for figure 1 because there are not two congruent figures. These figures are non-congruent. Okay? Is straight line BD a line of symmetry for figure 1? Why? Straight line BD is not a line of symmetry for figure 1 because these two parts are not congruent. From above, an isosceles trapezium has excellent one line of symmetry, which is the straight line passing through the midpoints of its pieces. Please look with me. Straight line MN is a line of symmetry for an isosceles trapezium ABCD. Line of symmetry MN passing through the midpoint of its pieces. M is a midpoint. N is a midpoint. Is the line of symmetry of an isosceles trapezium perpendicular to its bases? Excellent. Yes. Straight line MN is perpendicular on BC. You can verify by measuring using your protractor or set square. In figure 1 is figure A, M, N, B congruent to figure D, M, N, C. Why? Yes, these two figures are congruent. Please pay attention with me. Figure 2. There is no line of symmetry for non-isosceles trapezium. Figure 2 is called non-isosceles trapezium or scalene trapezium. Summary for you. Triangle, scalene triangle, zero lines of symmetry, equilateral triangle, three lines of symmetry, isosceles triangle, one line of symmetry. Square. Square has four lines of symmetry. Rectangle, two lines of symmetry. Trapezium, non-isosceles trapezium has zero lines of symmetry. Isosceles trapezium has one line of symmetry. Rhombus, two lines of symmetry. Parallelogram, zero line of symmetry. Circle, very large number of lines of symmetry. We can also say an infinite number of lines of symmetry. Pentagon has 5 lines of symmetry. Hexagon has 6 lines of symmetry. Let's start together. Exercise on symmetry. Put true for correct answer and false for incorrect one, and correct the wrong statement. The parallelogram has 4 lines of symmetry. Excellent. Wrong. Correct. Parallelogram has no lines of symmetry. The rectangle has 4 lines of symmetry. Excellent. False. Correct. The rectangle has 2 lines of symmetry. The scalene triangle has 3 lines of symmetry. Excellent. False. The scalene triangle has 0 lines of symmetry. The isosceles trapezium has 1 line of symmetry. Excellent. True. The square has 4 lines of symmetry. Excellent. 2. The rhombus has 4 lines of symmetry. False. Correct. The rhombus has 2 lines of symmetry. In the figure opposite, A, B, C, D is a square with midpoints of its sides X, Y, Z, N. These are midpoints on square A, B, C, D. Note the figure, then answer the following questions. Draw a common line of symmetry for 2 squares. How many common lines of symmetry are there for 2 figures? Do with me. The first common line of symmetry and why? XY is a common line of symmetry. BD is a common line of symmetry. AC is a common line of symmetry. So the 2 squares have 4 common lines of symmetry. Join each figure to its number of lines of symmetry. Join each figure to its number of lines of symmetry. Good time for you. Goodbye.